So we're moving on to section 8-5. And in 8.5 there is no vocabulary. This first slide I'm going to talk briefly about what the topic is and what we're doing. Then I'm going to have you go into Khan Academy and watch the video I have linked there. Then come back here for some examples so you get an idea of what we're actually doing here. So what we're really doing is undoing this whole FOIL idea. So if you remember what we've been working on, hopefully you remember, is something like this. X plus 2 times x plus 3. And when you FOIL that out, we end up with x squared plus 5x plus 6. So we're talking about doing the reverse, going back this direction. And the kind of things we look for here to sort of give you an idea of what we're doing is we take a look at the factors of 6, like 6 and 1, or 2 and 3. And we figure out, okay, well, how can I get a 5 by taking those factors? So what can I do to add and subtract to get that 5? Well, I could take 6 minus 1 and get 5, but the problem is it's a positive 5, so that's out. But I could also notice I can add 2 and 3 to get that 5. So again, I look at factors of the third term that I can add together to get the coefficient of the second term. So lots of examples here. So again, there's no vocab this section, and I do want you to go in and watch the Khan Academy video before you go any farther here. I also want to point out I've included another video in Schoology for you. It says it's a box method of factoring, and it's from another teacher on YouTube, so you're welcome to watch that one as well. It's another method of doing the exact same thing. Some folks like that one. Okay, so the last thing I want to note on this slide is that I've also included a link to a factoring calculator website that you might find useful. Yeah, it's kind of like cheating for your homework, but again, you can check it pretty easily, and it does give a nice explanation to help guide you through it, so that's why I like that one. So in here, it sounds like I'm talking about a special case when you look at the example from your book. It says factoring x squared plus bx plus c, where b is greater than 0 and c is greater than 0. Technically, all these follow the same process, but again, this is the simplest type of example. So we're looking at this, x squared plus 8x plus 15, and I want to figure out what two terms can I put in parentheses, so x plus something and x minus something, that when I multiplied them back out, I'd come back to this trinomial. So we look at that third term, that 15, and we look at factors of 15 that, when in this case, technically added together, provide 8. So, well, 1 and 15 are factors of 15, but there's nothing I can do with those to get an 8. It's going to get 16 or 14, again, depending on adding and subtracting. But 3 and 5 are factors of 15, and when I add those together, I do get 8. So here's the idea. I'm going to take the first term, x, right here, x and x, and then the factors of 15, 3 and 5, and right up here, and I get the multiplication, right, of two terms. So if you FOIL these back out, so I'd say x times x is x squared, 5 times x is 5x, 3 times x is 3x, and 5 times 3 is 15. And again, you combine like terms at 5x and 3x, you get the 8x in the middle, and there you go. So yes, obviously there's an expectation here that once you factor, that you check your work. This is an easy one to make sure you've got right. So you factor it out, and then you go ahead and refoil it to make sure you got the original term that you started with. So here we have one for you. We start with r squared plus 11r plus 24. So right off the bat, you should be thinking to yourself, what are terms of 24? So like 1 and 24, 6 and 4, 8 and 3, that when you add them together, you can get 11. So we know for sure. So always start like this. We know that r squared is going to be nothing more than r and r, because r times r is r squared. And then I look at factors of 24. So again, we talked about 1 and 24. We talked about 4 and 6, and we talked about 8 and 3. That when I add them together in this case, I'm going to get 11, that middle term. Well, we can see real quick here, these two are out. 4 and 6 is not going to give it, it's going to be 10. But 8 plus 3 is 11. So that means I'm going to have r plus 8, r plus 3. Now, again, I expect to see a check from you. That means you have to refoil this, because this is your answer right here. But I want you to refoil it so that you can find out if you're right or not. So r times r is r squared. And then we have 8r plus 3r plus 8 times 3 is 24. So that's r squared plus 11r plus 24. And that's it. That's what we're doing. So my answer, r plus 8 times r plus 3, was correct. So again, we mentioned that this is going to take the form of special cases. So notice this time our b, that middle term, is going to be a negative, and c is still a positive. So that third term is still positive. The method's going to work pretty much the same. What is the factored form of x squared minus 11x plus 24? So we know that in order to get that 24, we're going to have to multiply probably two negatives here that we're going to add together to get the middle term. So again, still looking at factors of 24. 1 and 24, that's not going to get me to negative 11. 2 and 12, negative 2, negative 12, that's going to get negative 14. Negative 3 and negative 8, again added together, yield negative 11. And negative 4, negative 6 yield negative 10. So we're going to use that minus 3 and minus 8. So again, what that looks like, you start out, we know for sure that it's going to be x times x at the beginning. That's going to yield our x squared. And we're going to say that we're going to use this one right here because negative 3 plus negative 8, which again when multiplied gives positive 24, added together give negative 11. So minus 3, minus 8. And again, I expect to see you check that. Foil that back out to prove that it did indeed work. So on this one, again we start with y squared minus 6y plus 8. And we know for sure we're going to have this. We're going to have y and y, because that's how we get the y squared. We've got to look at factors of 8. And again, we've got the middle term here is negative 6. So we're going to have to look at the negative factors. So negative 8 and negative 1, and negative 2 and negative 4. And I'm going to add these together. I get negative 9. That's not useful at all. I add these two together, though, and I get that negative 6. And that's what I'm shooting for. So we're going to have y minus 2, y minus 4. Again, I do expect to see the check here. You go back and you FOIL that, so you get y squared minus 2y minus 4y plus 8. So I get y squared minus 6y, because we combine like terms, plus 8. And that's what I was shooting for, so this is the correct answer. Part B, can you factor x squared to get x squared minus x plus 2 and explain? So let's take a quick look at that. And we're going to end up saying no to that for the following reason. Because I'm looking for the pattern here for the negative exponent. So I get negative 2 times negative 1. Well, that's it. And I can't combine those two in any way, shape, or form to get a negative 1. So we know this one cannot be factored. Okay, so now, again, another special case here, if you want to think about it that way. This time c is going to be less than 0, so c is going to be a negative. So that means we have to start looking at positive and negative factors of the third term, so that negative 15 that's going to yield, depending on the middle term here, positive or a negative. So, again, negative 15, factors of that, 1 and negative 15. Negative 1 and positive 15. 3 and negative 5. Negative 3 and 5. And we're looking at when we add those together, do we yield that middle term? Well, 1 and negative 15 is negative 14, so that's useless. Negative 1 and 15 yields a positive 14, that's useless. 3 and negative 5 yields a negative 2, that's closer to the positive 2. Obviously then 3 and 5 when added yield a positive 2. So I know that the factors I'm going to use are going to be x minus 3 and x plus 5. And again, I do expect you to FOIL that back out to prove it. So on this first one here, n squared plus 9n minus 36, we know for sure we're going to get the following. We're going to get n and n. It's the other ones I have to come up with. So let's go ahead and do that. So we start listing the factors. Now you're shooting for a positive 9 here. So certain ones you can leave out. You know that 36 and 1 and 36 and negative 1 aren't going to get you anywhere near what you need. You could look at, so again we're looking at factors here. So you look at negative 9 and 4. Well, that's going to yield a negative 5, so that's out. You look at 9 and 4. That's going to yield 9 and negative 4. That's going to yield a positive 5. That's not helpful. And you go through them. You could list 9 and 4 and negative 9 and 4. The ones that I'm going to find as you go through this, you're going to see we could look at negative 12 and 3 and 12 and negative 3. So these are the two that get you in that realm of 9. Well, negative 12 plus 3 is negative 9, right? So that doesn't do any good, just like these guys. But negative 12, or positive 12, plus a negative 3 does yield a positive 9, and that is indeed what I was looking for. So what that means is the factors I'm going to use is going to be n plus 12 and n minus 3. And I do expect you to FOIL that back out to check it. So we get that n squared plus 12n minus 3n minus 36. These two in the middle. So n squared plus 9n minus 36. So that means this was correct. Alrighty, so this next one, we have c squared minus 4c minus 21. So we have to look at factors of negative 21 here. And so we can list negative 21 and 1, 21 and negative 1, negative 7 and 3, and 7 and negative 3. And this is going to yield negative 20, not useful. This is going to yield positive 20, not useful. This is going to yield negative 4. And I guess I found it right there, didn't we? So that's what we're looking for, is that negative 4. So we don't need the other one then. So again, we start out with c and c. That's how we get the c squared. So c squared minus 7 and c squared, or sorry, c rather, plus 3. And again, I do expect you to FOIL that back out. C squared minus 7c plus 3c minus 21. And so we had c squared minus 4c minus 21. So this was the correct factoring. So in this fourth example, again, kind of the idea of a word problem here. The area of a rectangle is given by this trinomial. Now, if you remember, if you remember, a rectangle obviously looks like this, and we have length times width. So what we're looking for here is two terms, and when I multiply them, create this area, a length and a width. So really what I'm asking you to do is just to factor this. So we look at the negative 35, and we realize we're going to have a positive and a negative factor. So 1 and negative 35, negative 1 and 35, 5 and negative 7, and negative 5 and 7. And when I add those different factors, I find that the only one that works is the 5 and negative 7 to yield a negative 2 for that middle term. So again, what that looks like is x plus 5, x minus 7, and I do expect you to factor that, or to FOIL that back out to produce this trinomial. Very similar problem. We have x squared minus x minus 7. What are some possible dimensions? Use factoring. In other words, I'm going to factor this trinomial. And since our first term is just x squared, we know we're going to have an x and an x. And we need to have factors of 72 or negative 72 that yield a negative 1 when added together. So you can go through all kinds of them, right? You could start with 1 and negative 72, negative 1 and 72. Hopefully you know that 8 and 9 are factors of 72. So I could talk about a negative 8 and a positive 9, and an 8 and a negative 9. And when I add these together, here I'm going to get a positive 1, here I'm going to get a negative 1. And that's obviously what I'm shooting for. That middle term is a negative 1. Now obviously I skipped over listing out all the factors. The hope here is that you catch on. You start, that number sense kicks in. You start recognizing, well, what factors can I use in order to generate a negative 1 from 72? So what that means is we're going to have x plus 8 and x minus 9. And again, I do expect you to factor that back out, FOIL it back out rather, to ensure that that does indeed equal x squared minus x minus 72. Now I can throw multiple variables at you, but it doesn't change the process at all. So x squared plus 6xy plus 55y squared. All that means is when you write out before you start, you know for sure you're going to have an x and an x, and then you're going to have something y and something y. We still take a look at the factors of negative 55, and we're looking for, when we add those together, to get a positive 6. And you can see here we've listed those out, 1 and negative 55. You know right away that nothing you can do with 1 and 55, I don't care if they're positive or negative, is going to yield 6. But as I go through the factors, 5 and 11, well, again, positive 5 and negative 11 yields negative 6. Negative 5 and positive 11 does yield that negative 6. So that means you're going to have one of them here is going to be minus 5y, the other one is going to be plus 11y. And I do expect you to FOIL that back out to prove that it does indeed yield x squared plus 6xy minus 55y squared. So as a reminder, some things I put in Schoology for you. I have a Khan Academy I'd like you to try. And if you want to just watch the first video and that does it for you, great. Otherwise, there's a whole series of activities you'll see below that video on the left side when you go into Khan Academy. Also, I included the box method. There's a video on that in there. And then finally, I included a link to a calculator that factors these for you and guides you through the process so you can see how the answer was achieved. All things to help you get there when it comes to factoring these trinomials.